Another important article that is called as State and Explain. State and Explain. Stokes Law. State and Explain Stokes Law. This article carries 2 marks. It is related to 2 marks article. Okay. What the law states, that we will see first, that statement first. What the law states, that whenever, according to Stokes, whenever a small spherical body, you can say, or whenever a small sphere also, whenever a small spherical body or whenever a small sphere falls under the action of gravity, whenever a small spherical body falls under the action of gravity through a viscous liquid, through a viscous liquid, then the viscous force, then the viscous force acts on it is, the viscous force acts on it is directly proportional to, it is directly proportional to, number first, coefficient of viscosity. The first point, that is called as coefficient of viscosity. What is the statement? That Stokes' law states that whenever a small spherical body falls under the action of gravity through a viscous liquid, what happens? Then the viscous force is, this viscous force is directly proportional to, number one, coefficient of viscosity. Number second, it is also directly proportional to radius of a sphere. It is also directly proportional to radius of a sphere. Number third, it is also directly proportional to velocity. It is also directly proportional to velocity of a body. Mathematically, it can be written as, mathematically, above statement, mathematically, above statement can be written as, yes, what is the statement? The viscous force that is represented by the factor F, it is directly proportional to, number one, coefficient of viscosity, it is represented by the factor eta, equation number one. Again, the viscous force, it is directly proportional to radius, so F is directly proportional to R, equation number second. Again, the viscous force, it is directly proportional to velocity, so we can write F is proportional to P, equation number 3. Okay, combining equation 1 comma 2 comma 3, yes, we get what we get, that is F is directly proportional to eta RV. F is directly proportional to eta RV, or it can also be written as, that is F is equal to 6 pi eta RV, where 6 pi, it is the constant factor put forth by the scientist Stokes. That's why it is called as, so this is the required formula for This is the required formula for Stokes law. Okay. Whenever question asked related to Stokes, that state and explain Stokes law, then you must have to learn, you must have to well familiar about its formula, that is F is equal to 6 pi eta RV. As soon as you hear Stokes law, you must have to recall your memory that F is equal to 6 pi eta RV, where 6 pi is the constant factor. What is F? F is the viscous force and it is directly proportional to eta, that is coefficient of viscosity. F is directly proportional to radius, that is R. F is directly proportional to velocity. So what we can write? F proportional to eta, F proportional to R, F proportional to V. Combining 1, 2 and 3, we get F is equal to 6 pi eta RV. Okay, watch it. Law. Another important law that is called as state and explain. State and explain Newton's law of viscosity. Newton's law of viscosity. What is the question? State and explain Newton's law of viscosity of the same type that we seen in Stokes law, that first of all in the answer we can write the statement first. The side heading first we have to write statement. What the Newton's law of viscosity states? The Newton's law of viscosity states that the Newton's law of viscosity, the Newton's law of viscosity states that for a streamlined flow, the viscous force is, for a streamlined flow, the viscous force is the first point. What the viscous force does? The viscous force is, the first point, is directly proportional to, the viscous force is directly proportional to area. The very first point, the viscous force is directly proportional to area. Number second point, the viscous force is, yes, it is also directly proportional to velocity gradient. It is also directly proportional to velocity gradient. Okay, this is in a statement form. Okay, mathematically above statement can be written as follows. It can be written as follows. Yes, what is the statement? The first point, that the viscous force is directly proportional to area. Viscous force F directly proportional to area A. Equation number 1. Okay, another, again viscous force is directly proportional to velocity gradient, that is F is directly proportional to dV by dx. Okay, dV by dx, nothing but velocity gradient. Okay, combining equation 1 and 2. Combining equation 1 and 2. Yes, what we can write? That is F is directly proportional to A and dV by dx. F is proportional to A into dV by dx, or F is equal to eta. F is equal to eta into A into dV by dx. Okay, so this is the general formula for, this is the general formula for or this is the required formula for Newton's law of viscosity. What do we understand by Newton's law of viscosity? The Newton's law of viscosity states that the viscous force is always directly proportional to area. It is directly proportional to velocity gradient. Mathematically, this statement can be written as F proportional to A, F proportional to dV by dx. Combining 1 and 2, we can write F proportional to A into dV by dx. Or F is equal to eta into A into dV by dx. What is eta? Eta with a constant factor called as coefficient of viscosity. What do we understand by eta? Eta with a constant factor and which is called as coefficient of viscosity. Mathematically it can be written as, that is, eta is equal to, we can write eta is equal to F upon A into dV by dx. Okay, eta is equal to F upon A into dV by dx. So define coefficient of viscosity. What we can write? Coefficient of viscosity, eta, coefficient of viscosity is, it is nothing but, or the coefficient of viscosity is equal to, coefficient of viscosity is equal to viscous force. It is equal to viscous force. Eta is equal to F. When eta will become equal to F? If coefficient of viscosity is equal to viscous force if there is unit area of cross section, if there is unit area of cross section and unit velocity gradient, that's all. What do we understand by coefficient of viscosity? Coefficient of viscosity is always equal to viscous force. When it is equal to viscous force? If there is unit area of cross section and unit velocity gradient. In another way, it is the ratio of coefficient of viscosity. It is the ratio of viscous force per unit area and per unit velocity gradient. Watch it carefully. Another article that derives Boyle's law. Derive Boyle's law on the basis of kinetic theory. On the basis of kinetic theory of gases. Okay. The question is that derive Boyle's law on the basis of kinetic theory of gases. Okay, in simplest way we will discuss it, how Boyle's law obeys or how Boyle's law is obeyed in simplest way. Let us consider the simple form, that the pressure exerted by the gas. Let us consider the general formula for the pressure exerted by the gas. The formula, that is P is equal to 1 upon 3 mn bar C square upon V. The pressure exerted by the gas is P is equal to 1 upon 3 mn bar C square by V. Or it can also be written as, that is P is equal to 1 upon 3 in place of mn. In place of mn we can write capital M bar C square upon V, where capital M, it comes in place of mm, so it becomes P is equal 1 upon 3 capital M bar C square by V. Now see the question, what we are dealing with. We are dealing with Boyle's law. Boyle's law, it means nothing but it is in the form of PV. Boyle's law, it is in the form of PV. So make it in the form of PV. So here P is there, V is there, multiplied them, what we get? PV is equal to 1 upon 3 m bar C square. When we multiply it to P, it becomes PV. So PV is equal to 1 upon 3 m bar C square. Okay. We can write it in this way also, or it can also be written as, that is, PV is equal to 2 by 3 into 1 by 2. We adjusted it. 1 by 3 can be written in this way, 2 by 3, 1 by 2. Multiply 2 to the numerator and 2 to the denominator. It remains as it is. What remains? M bar C square. Okay, what do you understand by M? M be the mass. This M is nothing but the mass. What do you understand by C? C be the velocity. And from high school level, you are well familiar that 1/2 mass into velocity square. That is nothing but the kinetic energy. So what we can write? So PV is equal to 2 by 3. What this factor complete becomes? This is nothing but the kinetic energy of a gas. According to assumptions of kinetic theory of gases, according to assumptions of kinetic theory of gases, what the assumption tells us? That kinetic energy of a gas is constant at constant temperature. What the assumption tells us? The assumption of kinetic theory of gases tells us that kinetic energy of a gas is constant at constant temperature. So this factor is constant here. So what we can write? So PV is equal to 2 by 3 into constant. Something multiplied by constant, it becomes constant. So PV is equal to constant here. Thus, PV is equal to constant. Thus, here Boyle's law obeys. Thus here Boyle's law obeys. How we obeys here? We know the pressure exerted by the gas. P is equal to 1 upon 3 mn bar C square by V. This small m into capital M written as capital M bar C square by V. What is the question? Boyle's law. Boyle's law is in the form of PV. So multiply this P and V. It becomes PV is equal to 1 upon 3 m bar C square. We can write it in the same form, but just by doing the multiplication 2 to the numerator and 2 to the denominator. So it becomes 2 by 3, 1 by 2, m bar C square. M be the mass, C bar C square be the velocity square. So 1/2 mv square, that is nothing but the kinetic energy. And it is said that according to assumptions, kinetic energy of a gas is constant at constant temperature. So this factor remains constant. PV is equal to constant. Hence, Boyle's law obeys here. Watch it. After Boyle's law, show that kinetic energy per unit volume is equal to 3 by 2 P. Show that kinetic energy per unit volume is equal to 3 by 2 P. First of all, the pressure exerted by the gas. The general formula, the pressure exerted by the gas, yes, that is P is equal to 1 upon 3 mn bar C square upon V. This is the general formula of pressure exerted by the gas. Or it can also be written as P is equal to 1 upon 3. This factor we can write capital M bar C square by V. Okay, so these are the two lines. Now watch the question carefully. In the question, kinetic energy is there. So we have to make the kinetic energy here. We have to do the arrangement as per the question. In the question, kinetic energy. So make the answer in the form of kinetic energy. How? Watch it. P is equal to, we can write 2 by 3, 1 by 2 here. 1 by 3 is there. We are adjusting it just by multiplying 2 to the numerator and 2 to the denominator. What remains here? M bar C square upon V. Okay. So P is equal to this 2 by 3 as it is. What do we understand by this factor? 1/2 mc square, that is 1/2 mass into velocity square, and this is nothing but kinetic energy. What is this? 1/2 m velocity square, that is nothing but the kinetic energy. To the denominator, what is there? V. V is nothing but volume. Okay, V is nothing but volume. So come from this side. If we are coming from this side, that is kinetic energy per unit volume is equal to, it becomes, this 3 multiplied it here, it becomes 3 by 2p. Hence the proof. Watch it carefully. Hence the proof. How it happens? Show that kinetic energy per unit volume is equal to 3 by 2p. How to obtain? We know the pressure exerted by the gas. That is P is equal to 1/3 mn bar c square by V. Or P is equal to 1/3. This is nothing but capital M bar c square by V. Adjust it as per the question. In the question, kinetic energy is there. Adjust it. That is 2 by 3, 1 by 2 m bar c square by V. P is equal to 2 by 3 as it is. What is this? 1/2 m velocity square, that is nothing but the kinetic energy, upon V, that is nothing but the volume. So if we are coming from this side, that is kinetic energy per unit volume is equal to 3p by 2. Hence the proof. Watch it. Another important article that show that kinetic energy per mole is equal to 3 by 2 pb. So that kinetic energy per mole is equal to 3 by 2 pb. How to start? The same answer, that we know the pressure exerted by the gas. We know the pressure exerted by the gas, that is nothing but P is equal to 1/3 mn bar c square upon V. Same start. This factor mn we can write, that is P is equal to, or P is equal to 1/3 capital M bar c square upon V. Okay, this is the second line. Now go to the question. What is in the question? In the question, kinetic energy is there. To do the adjustment, that is P is equal to, multiply 2 to the numerator and 2 to the denominator. What remains there? M bar c square upon V. Okay, so P is equal to this 2 by 3 as it is. What is this? This factor, this is nothing but kinetic energy. Okay, this is nothing but kinetic energy. Just multiply the V here. So what we can write? That is P is equal to, just multiply the V. It becomes PV is equal to, we are multiplying here PV. Why we are multiplying PV? See the question. In the question, PV is there. Multiply the factor P and V. We get PV. Again, what is in the question? Kinetic energy is there. So we can write, that is PV is equal to 2 by 3. What remains here? Kinetic energy, that is 1/2 m c square. So how we can write it in this way? That P is equal to 2 by 3 kinetic energy per unit volume V. Keep it as it is. You are well familiar with the starting point, 1/3 mn bar c square by V. This mn can be written as capital M. Okay, now in the question, kinetic energy, so 2 by 3, 1 by 2 m bar c square by V. What is again in the question? In the question, PV is there. So P is equal to 2 by 3, this factor kinetic energy upon V is there, multiplied the PV. So we get PV is equal to 2 by 3 kinetic energy. Nothing is there, that is, we name it as per mole. Per mole, that is 1. So what we can write? Thus we are coming from this side. Thus kinetic energy per mole is equal to, yes, kinetic energy per mole is equal to 3 PV upon 2. Hence the proof. Watch it carefully. Okay, watch it. Now let us consider, show that RMS velocity, that is root mean square velocity, represented by the factor c, show that RMS velocity c is equal to under root 3 RT upon m. Okay, show that RMS velocity c is equal to under root 3 RT by m. Sometimes it is asked in this way, or show that RMS velocity is directly proportional to square root of absolute temperature. How the question and how the answer is there? Watch it. We are well familiar about the starting point, that let us consider pressure exerted by the gas. The start is same, pressure exerted by the gas. What is the general formula? That is P is equal to 1 upon 3 mn bar c square upon v. And you are well familiar that about mn, what we can write, that is P is equal to 1 upon 3 capital M bar c square by v. Okay, this is up to second line. Now the third line based on the question. What is there? C is equal to, we have C here. Yes. RT is there. RT, we know that according to ideal gas, PV is equal to RT for 1 mole. So to get RT, we have to multiply this P and V. Why we are multiplying P and V? To get RT. So we can write that is PV is equal to 1 upon 3 m bar c square. Okay, to get RT, we have multiplied here P and V, that is PV is equal to 1 upon 3 m bar c square. And we know that PV is always equal to RT. How? For 1 mole of a gas, PV is equal to RT. And according to ideal gas, so what we can write? This PV can be written as, that is nothing but RT is equal to 1 upon 3 m bar c square. Okay, again see in the question, RT we have got, we have capital M. Now C is there and we have C square. So take it in the form of C square. So what we can write, that is bar C square is equal to, we are coming from this side. From this side we are coming, bar C square is equal to, what happens? This 3 multiplied to this RT. It becomes 3 RT. What remains? Upon M. Bar C square is equal to 3 RT by M. This is bar C square. Taking square root. Okay. Taking square root. This bar C square becomes only C. So C is equal to under root 3 RT by M. Okay. Hence the proof. C is equal under root 3 RT by M. What about R? R with the gas constant, M with the mass of a gas. So again we can say that is C, that's why C is directly proportional to square root of absolute temperature. How? If here R and M are constant. Okay, here R and M are constant. That's why C is directly proportional to square root of absolute temperature. That is RMS velocity is directly proportional to square root of absolute temperature. Watch it carefully.